Hello, ladies. These are your notes for section 7.1. I unfortunately am not feeling well, so I'm going to try to keep my voice up and not sound too monotone um, and get through this video for you all. So, let me just say this will probably be, I'm going to try to keep this in two videos, and I try not to go over 15 minutes in each video. So, let me just give you fair warning throughout the video or videos. There will be some questions that you will answer in the quiz that I'm going to post in Moodle a little later. By the time you look at this, it should be posted in Moodle. And so just make sure you watch the whole entire video, go through the steps, give yourself enough time to actually, because I like to be interactive in the video, so I like to give you a chance to like pause the video and see if you can work it out on your own. So give yourself enough time. Don't just think, oh, it's a 15-minute video, I only need 15 minutes or whatever to do this, okay? Some things I will leave out that you'll have to look up on your own. And so let's get started. And that one thing are the definitions. So I still want you to do the definitions on your own. I'm not going to waste time going over the definitions here. I will say, though, to give you a heads up, that on the quiz, one of these definitions you will have to define. So my advice would be to write out all the definitions first, because once you start the quiz, you're only going to have a fixed amount of time, and you want to make sure you have enough time to finish the quiz. So make sure you complete all the definitions. I repeat, complete all the definitions before you begin your quiz, because one of those definitions I'm going to ask you to define in the quiz. All right, so we're just going to go straight. So assuming that you've already went through the definitions and read through the definitions, we're going to get started with the examples. You will also need your standard normal distribution table, table E, with you for the quiz and for the notes here. So make sure you have that out as well. All right, ladies, so let's get started with example one. So there is a typo, and I didn't finish writing the problem in example one. That's what happens when you rush to get things done in time. But anyways, so I'm going to add it on, and I'll show you what to add on in a minute. But in this example, so it says a researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo. I think that's how you say it. A random sample of 50 cars had a mean time on the dealer's lot of 54 days. So now that other part that I have, sort of cross that out, and I want you to write this in. So assume the population standard deviation is 6 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. Okay, and so just a note here. So in this box over here, assumptions for finding a confidence interval for a mean when standard deviation is known. So in the heading of this section, it says finding confidence intervals when the mean is known. So in 7.2, we're going to learn, so when I return, we're going to learn about how to find confidence intervals when the mean is not known, when the standard deviation is not known. But in all these examples, we're going to be given the standard deviation of the population, okay? So assume the population standard deviation is 6 days. Okay, I read that, right? So here's the formula. So this is also very important, so make sure you write this down. So the formula for the confidence interval of the mean for a specific alpha when standard deviation sigma is known. And here's the formula here. So it's X bar, which you should remember represents our sample mean, right? So that's our sample mean. And we'll either be given the sample mean or you'll be given the data points to find the sample mean. And you all know how to do that. Just add up all the numbers and divide by how many numbers you have. For your worksheet or your fun sheet that I left for you all for Monday, feel free to use Excel to put the data in, or you can use your calculator. But just know you can also use Excel, put in the data, and then automatically get your mean that way, your sample mean. Okay, so it's X bar minus Z sub alpha over 2, which we'll talk about in a minute, times standard deviation over the square root of n. So I'm looking at this over here, and that's less than, this is the true mean of the population, and it's the confidence interval is between what I just read on the left and then X bar plus Z alpha over 2 times the standard deviation over divided by the square root of n, okay? For this, since we want to know 95% confidence interval, so let's get our data together. So we know we have n, so if you read back over the problem, what's our n? Our n is 50, right? Because we have a random sample of 50 cards. Our sample mean, so our x bar is also given, and that's 54, okay? And we want to know the, oh, I forgot to answer the first question. So the best point estimate of population mean. When you're reading the problem, so let me go back a little bit. And I have to break this up into 2 slides because of I don't have the space on the program that I'm using, but you should be able to fit all of this problem on that one page that you were provided. Okay, and so for the first thing they ask you for, so find the best point estimate of the population mean, the sample mean will always be the best point estimate of the population mean. So that question is just asking for the sample mean. So you would just say the best point estimate is the sample mean. And from now on, if you're asked for it, you don't have to sort of repeat this line. You could just jump right to what the sample mean is, okay? So thus, our best point estimate of the population mean, so thus 54, and we're looking at days as our units. Okay, so let's now go to B, and I'm going to have to use a new slide to do B, which is asking us for the 95% confidence interval of this population mean. All right, so again, so now we're going to be using that formula x bar minus z alpha over 2 sigma over the square root of n less than mu less than x bar plus z alpha over 2 times sigma over the square root of n. And so we know n is equal to 50, x bar is 54, and our standard deviation is 6. All right, so I'm just going to tell you for this, but in the I think the next example I'll show you how to calculate the z alpha over 2. But for this example, because we want a 95%, so for a 95% confidence interval, z alpha over 2 will always be 1.96. That's staying fixed for any 95. They ask for a 95% confidence interval, c sub alpha over 2. So it's z sub alpha over 2 because that's a subscript. So z sub alpha over 2, and let me write that out. So z sub alpha over 2, that's how you say it. And hopefully that yellow, you can see that yellow is not too light. Okay. Now we just plug it into our formula. All right. So take a minute and pause the video and plug in the values into this formula. All right, and so when you plug it into your formula, that's how it should look there. That's sort of how it should be set up. And when you calculate that, you should get those values. If you're not getting those values, then please check your calculator. I know some people are having problems with calculation, so you can use parentheses as much as you want, as long as you use them correctly. So if you wanted to, you don't really need to here, but if you wanted to say put parentheses around there and then put sort of some parentheses around there to do your subtraction or your addition, you can do that if you're not getting these values. Okay. Okay, so to conclude this problem, this is how, so right here, this is what you would state to conclude your problem. So therefore, we can say with 95% confidence that the population, put a comma there, that the population mean will be between 52.3 and 55.7 days based on a sample of 50 vehicles or automobiles. Be careful you make sure I sort of, was not put in haphazardly, but you really need to be careful, especially, like I said, statisticians can sort of finagle the data. So when you're looking at now, I want you, hopefully after leaving this class, you'll be more informed to read data with caution and look to see, well, how many samples did they take or where did they take the samples? And so it's important to put what was in your sample space for that. Okay, let's move on to the next example. Okay, so example 2 is finding out how do you find that z of alpha over 2. So how do we know that for a 95% confidence interval, our z alpha over 2 will be 1.96? Like, how do we know that? Okay, well, this is the process, and it's pretty straightforward. It's a little intuitive, but it's pretty straightforward once you get it. And so I sort of broke it down because I like, whenever possible, to write things in steps. And so I sort of broke this down into 4 steps, and hopefully this will be helpful, and you all will be able to find your z alphas over 2. Because I could ask for, you know, a 90% interval, a 80. I mean, although 80% is sort of on the low end, but I could ask for it. So you would need to know how to calculate any type of confidence interval, 92%, 93%, 93.5% confidence interval. Okay, and so here's the picture. So notice that this here is representing 95% of the data. Okay, so the first thing, and remember, probability and area under that curve, they go hand in hand. So the first step in this process is taking that area, subtracting 1 from whatever confidence interval you're looking for. So in this case, it'll be 1 minus 0.95. Okay, and we do the correct arithmetic on that, it's 0.05. Now this represents this is actually your alpha. Okay, so that's your alpha when you take 1 minus whatever the confidence interval is. So if it was a 93% confidence interval you were asked to find, it'll be 1 minus 0.93, and that would be your alpha. So that's your alpha. The second step in this process is to take your alpha and divide it by 2. And the reason why you need to do that is because, remember, in our normal distribution, it's symmetric, right? So since this is representing 95%, both these together represent the 0.05. Okay, so you need to divide by 2 because we want to sort of just look at one of those. All right, so if we take that and divide by 2, then we're going to get 0.025. And that 0.025 always represents the area to the right. So it's representing that area there, that 0.025. It always represents the area to the right. Okay. Your table, as you know, only gives you area to the left. So step 3 then would be to take 1 minus 0.025, because you want to use your table to find your z of alpha over 2. And when you do that, you get 0.975. Okay. And then the last step is to now look on your normal distribution, standard normal distribution table, and find out what's the closest z-score to. If it's not exactly 0.975, then find out what's exactly the closest to z of alpha over 2. So you can possibly go over a little. So just sort of ignore my comment about don't go over. You can go over if that going over is closer to staying under. Hopefully that makes sense. And so if you look on your chart, you'll see that 1.96 will give you I think it's exactly 0.975. Okay, and so that's how you find your z of alpha over 2, z sub alpha over 2. Okay, and so for B, we'll just quickly do B. Okay, for B, we see that if we look, so if we call that A, for B here, these two pictures actually go hand in hand. Notice this is the 98% confidence interval. So you take 1 minus 0.98, which is 0.02, that's your alpha. Take alpha divided by 2, you should get 0.01. That's step 2. Step 3 is take 1 minus 0.01, 0.99, and then step 4 is to look for the closest value to 0.99. And so you should get a z sub alpha over 2 score of 2.33. Okay, and that's how you find your confidence interval.